Okay, class, welcome back. We are in the last section of chapter 3. This is a very short section, and we will be dealing with the asymptotes of rational functions. So, the good news is we are not actually going to graph any of these, even though the title says graphs of rational functions. We are only going to be looking at the asymptotes, and basically you're going to find the asymptotes from the equation. So basically, if you remember, back in section 2 of chapter 2, we did the domain of a rational function. So we looked at a function and we said anything that makes the denominator 0, we could not use. So the domain was determined by the zeros of the denominator. We're going to kind of use that idea. Basically, again, those were restricted values that we could not use in our function. So that's basically what an asymptote represents, is any restricted value or any value that does not make the function true. So I did give you a graph so you could see what it would look like, okay? So these dotted lines, we have two red dotted lines. Here is a horizontal one, and then over here is a vertical one. These are the asymptotes. So these are the undefined values of this function, okay? And there's two different methods to find them. We're going to look at how to do that. So basically, you're going to be given a function like this one down here, g of x, and you're going to be asked to find the asymptotes for that function, okay? And it's not very difficult. That's why this is a very short lesson. We're not going to graph anything. We're not going to find the information from a graph. We're just going to look at the equation and determine the asymptotes. All right, let's see how that works. So we're going to start with the vertical asymptote because that is the easy one. So the vertical asymptote is found by getting the zeros of the denominator. So if a real number is a zero of the denominator, then it is a vertical asymptote. Why is my line not showing up right? Try that again. There we go. So the zero of the denominator of the function. And if you notice here, it's listed as x equals a. So when you list the asymptote, or when you find the asymptote, it represents a line. So it is actually an equation of a line. So a horizontal line has a vertical line has an equation of x equals a, okay? So for the horizontal asymptote, it's a little bit different. We need to look at the degree of the numerator and denominator, and we're going to compare those. So the degree, just as a reminder, is the highest exponent, okay? Now, I'm going to recommend for this, you only worry about the first two cases. When the numerator is less than the denominator degree, or when the numerator is equal. So if you know those two, the third one, when the numerator is greater, just means there's no asymptote. So when there's a horizontal asymptote, if there is one, there will not always be one, but if there is one, there is only one. There can't be more than one. Now with the vertical, we could have more than one. So keep that in mind. Make sure you remember that when you're doing these problems. Okay, so let's look at the horizontal again. So when the numerator is less than the denominator, then the asymptote is automatically y equals 0. Okay? If the numerator is equal to the denominator, so if the two highest exponents are equal, then the asymptote is going to be the quotient of the leading coefficients. Okay? We'll look at how that works. All right, so let's take a look at these examples. Again, this is a very short section, so there's not much to it. Now, I'm going to actually turn this into a little chart. So let me put some lines here. I'm going to separate these equations. And on the top of our chart, we will do the vertical. And on the bottom of our chart, we will do the horizontal. So remember, the vertical is just the zeros of the denominator. So what makes this denominator 0? So basically, we need to factor it. So if we say x squared minus 5x minus 6 equals 0, if we factor that, we get x minus 6 times x plus 1. And if I solve both of these, I get x equals 6 and negative 1. So those are my two vertical asymptotes, x equals 6 and x equals negative 1. Again, you need to write it as an equation. Put a note up here for that. Write asymptotes as equations. Okay. All right. So let's take a look at number 2. I'm going to do all the verticals first, and then we'll come back and do the horizontals. So number 2, we got x squared minus 64. So again, we want to do x squared minus 64 equals 0. If we add 64 to both sides, we get x squared equals positive 64. And then we can use the square root method to solve. So take the square root of both sides. X will equal 8 and negative 8. So x equals 8, x equals negative 8. Those are our two asymptotes for function g in number 2. All right, number 3, same thing. We're looking for the zeros of the denominator. So x squared plus 2 has to equal 0. And if we subtract 2 from both sides, we get x squared equals negative 2. And we need to take the square root. So here's the problem. We can't take the square root of a negative number and put it on a graph because we're going to get an I. That's a complex root or an imaginary number. So you have to get a real number for your asymptote. Now, it could be the square root. So if there wasn't a negative there, we would have radical 2 and negative radical 2. That's okay. But since there's a negative inside the radical, what that means is for this one, there are no vertical asymptotes. So it is possible that you don't have any. It has to be a real number. Okay, let's take a look at horizontal. So for horizontal, we're going to compare the degree of the numerator and the denominator. Scroll up so we can see that. There we go, right there. So remember, this x is x to the first. So we have x to the first. And we have x squared. So the numerator is less than the denominator. So 1 is less than 2. This is the numerator. This is the denominator. So that means our asymptote is y equals 0. Simple as that. Okay. In number 2, the numerator is 2 and the denominator is 2. So 2 is equal to 2. Numerator equals denominator. So then we're going to look at the, let me scroll down a little bit so I can see it, the quotient of the leading coefficients. So the leading coefficient here is a 1. The leading coefficient here is a 1. So 1 over 1 equals 1. So our asymptote here is y equals 1. Okay. And then finally, the last one, well, there's no x here, but remember, 10 by itself is the same as 10x to the power of 0. So we have 0 and we have 2. 0 is less than 2, numerator, denominator. So here it's also going to be y equals 0. So my only caution to you on this is make sure you look for the highest exponent. Just because it's the first term in one of these, in the numerator or the denominator, doesn't necessarily mean it's the highest exponent. If the expression is not in standard form, then you need to look at all the terms and pick the one with the highest exponent. So make sure you look for that. That is all there is for section 5. So all you need to do again is find the vertical and the horizontal asymptotes from the function. Have a great day, and we will see you next time.